Hey everyone, welcome to my channel. What happens when an attacker floods your network with traffic? Well, today, we're going to find out firsthand as we simulate an ICMP flooding attack in a controlled environment using ICMP. In this video, I'll walk you through my setup, how I configured the attack, and the impact on the system's performance. Let's dive into the lab. Here we are in ICMP. I've set up a simple but effective network topology for our test. We have two devices, a Kali Linux machine acting as the attacker, and a router serving as the victim. The router will be the target of our ICMP flooding attack, and will monitor its CPU usage as well as network traffic during the attack. With the router configured, let's run a basic ping test between the Kali machine, the attacker, and the router to ensure connectivity. As you can see, the ping is successful, and everything is working as expected. Next, let's monitor the CPU usage of the router. It's important to establish a baseline before we initiate the attack. Here you can see the router's CPU usage is pretty stable at around 10 to 15%. Everything is normal. Now, it's time for the action. Using ping 3, I'll launch an ICMP flooding attack from the Kali machine. Ping 3 is a tool that allows us to craft custom packets, and today, we'll flood the router with ICMP echo requests, the same packets used in the ping command. Let's take a look at the router's CPU usage now. As expected, the attack starts to overwhelm the router's network interface, and the CPU usage spikes dramatically to about 94%. This shows the power of flooding attacks. Even a simple ping can bring down a system if it's not protected properly. Let's take a look at the router's CPU usage now. As expected, the attack starts to overwhelm the router's network interface, and the CPU usage spikes dramatically to about 94%. This shows the power of flooding attacks. Even a simple ping can bring down a system if it's not protected properly. To get a closer look at what's happening on the router, I used the debug ICMP command. This command lets us see the ICMP packets in real time as the router processes them. It helps us understand how the router is dealing with the incoming flood and where the bottleneck occurs. So, what did we learn from this attack simulation? First, ICMP flooding is a real threat, and even a basic router can be overwhelmed without proper defenses. The CPU usage jumped to 94% under the attack, showing just how critical it is to have strong security measures in place, like rate limiting, firewalls, and intrusion detection systems, IDS, to mitigate such attacks. By simulating this attack, I gained valuable insights into network vulnerabilities and how we can better prepare for real-world scenarios. If you found this video helpful and want to see more network security tests and simulations, make sure to like, share, and subscribe. Have any questions or suggestions for future videos? Drop them in the comments below, and I'll be happy to help. Thanks for watching, and stay secure.